Can you hear me?
Yes, sir. Yes, sir.
Okay, thank you.
Good evening, sir.
Yeah, good evening. Sorry for delay. So actually, I am faced some networking issue. So now I hope it will be work. Yeah. Okay, so welcome to the second day's online training program. So after completing the live training program, then I talk about the problem solving for the previous class. If face any problem, then we talk about that after completing the 3 hours live training program. Then we talk about that. Okay, so now we will start. Let me share my screen. Okay, can you see my screen? Is it visible?
Yes, sir. Yes.
Okay, thank you. Okay.
Zatarz. Stała.
Yes, so I hope everyone can hear me properly. Yeah, can you hear me properly? Yeah. Huh? Okay, thank you.
Yes, yes.
Okay. So now we'll start today's session. So basically, today is our second day's online training program. First of all, I try to explain about that our course content for the second day. Then try to start our class. So for today's session, I will try to discuss about that how we can easily filtering and displaying the satellite images, mainly Landsat or Sentinel imagery. How we can easily filtering and displaying that satellite imagery in Google Earth Engine. And then talk about that band combination, how we can easily use the different types of band combination, such as natural color, false color, or any other kinds of band combination. How we can easily apply in Google Earth Engine. I also try to discuss about that, and we will talk about that how we can easily export the satellite imagery. So actually in Google Earth Engine platform, we can easily export the different types of satellite imagery, and further we can also use it for other types of work. We also talk about that how we can easily import, filter, reduce, clip, and display the data in Google Earth Engine. Then we also talk about the time series chart, how we can easily create the different types of time series chart in Google Earth Engine, and then export any shapefile, how we can easily export the different types of shapefile in Google Earth Engine. We also try to discuss about that, and then calculating any indices from satellite imagery. We also try to discuss about that. So let's go one by one. We try to complete all of topic. So first of all, Google Earth Engine have a data catalog. Okay, so in this data catalog, we can easily access all of data set. It can be Landsat, Sentinel, MODIS, or different types of satellite imagery. We can easily access from that Google Earth Engine public data catalog. And this data set is updating daily. Okay, so from this data set, we can easily access the update data set. It will be updating daily, and all of freely available data set for remotely sensed data we can easily access from Earth Engine public data catalog. And this is the link about that. You can simply go to this link, then you can easily get all of Earth Engine public data catalog. So today's session I talk about that how we can easily filtering and visualizing the satellite images in Google Earth Engine. Okay, so basically filtering, when you filter any types of satellite imagery, it defines the three factor. First factor is that region of interest. Suppose you need the satellite image for a specific boundary. Suppose you need the satellite images for the Dhaka city boundary or any specific other location, other geolocation, you need the satellite images. So first factor is that region of interest. Second factor, it can be image properties. Suppose you need only for those image, which image will be not more than 1% cloud cover. So it's the another factor for filtering. Third factor is that a specific time period. Suppose I need the image for year of 2017, or I need the image for year of 2017 month of January, or summer season or rainy season. So any kind of satellite imagery in Google Earth Engine platform, when you filter, we just follow the three factor. First factor is the region of interest. Where you need this image. Suppose I need the image for the Dhaka city. How you need this image? Suppose I need this image only for the less than 1% cloud cover. Cloud cover cannot be more than 1% cloud. So this is another factor. And third factor is that a specific time period. Suppose I need the image for year of 2017. I need the image for year of 2017 month of January. So any specific time. So using these three factor, we can easily filtering our image collection. So let's check the practical example. Then you can also get the more better idea. So let me open my code editor. So just I open the code editor. Okay. So here you can see when I just click on here, we can get the browse data catalog. Okay. So when I click on the browse data catalog, then we can easily get all of satellite imagery, mainly Earth Engine data catalog. Okay. So this is our Earth Engine data catalog. In this Earth Engine data catalog, we can easily access all of imagery, all of data set. You can see climate and weather data, surface temperature, climate data. Also, you can see about that atmospheric data, weather data, image, different types of imagery, Landsat, Sentinel. Also, you can see the MODIS data set, high resolution imagery data set, geophysical data set, train data set, land cover data set. So all of data set we can easily access from here. So this called the Earth Engine public data catalog. Also, you can see when I click on the Landsat, then I can got all of Landsat image collection, such as Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So all of Landsat image collection I can easily get from here. Also, you can see when I click on the Sentinel, then it will be appears all of Sentinel image collection, such as Sentinel 1, Sentinel 2, Sentinel 3, Sentinel 5 Profomi or tropospheric monitoring instrument, all of Sentinel data, so you can easily access from here. Also, you can see the MODIS. When I click on the MODIS, then I can get all of MODIS data set. Okay, so all of MODIS product we can easily access from here. All of MODIS data set we can easily access from here. You can see. Okay. Suppose I click on the Landsat. Just I click on the Landsat. So here you can see Landsat, mainly Landsat 9. It for different time period we find out the different Landsat collection. Such as you can see Landsat 9 available from 2021 to present time. Landsat 8 is available from 2013 to present time. Landsat 7 is available from 1999 to 2021. So it's available from here. Also you can see about that Landsat 5, 1984 to 2012. It's available. Landsat 4 TM, it's available from 1982 to 1983. This time period we can get the Landsat 4 TM. Landsat 1 to 5 we find out that 1972 to 1989. So all of image collection you can see it's available. And when you filter, suppose Landsat 9, Landsat 8, Landsat 7 is the same approach. Okay, is the similar approach all time we apply. If you know Landsat 8, then you can easily apply it for Landsat 7. If you know Landsat 7, you can easily apply it for Landsat 4. Because it's totally similar approach for all time we follow. Okay, so all time. Suppose I just click on the Landsat 8. So now I can get all of Landsat image collection. Here you can see basically we can get this type of reflectance. One is the surface reflectance, another is the top of atmosphere reflectance, another is the raw image. So for the different purpose for remote sensing technique or remote sensing application, we have to use the different imagery. Sometimes surface reflectance is very well for land use land cover, or surface reflectance is also very well for land surface temperature monitoring. Okay, as well as also top of atmosphere. It also used for creating making the different types of indices such as NDVI, NDWI, or other types of indices we can easily create using the top of atmosphere. And this is surface reflectance. So both of image for filtering is the same process. Okay, suppose I just click on the surface reflectance. So now we can get all of information about this image collection. So here you can see we can get the dataset availability. Okay, so this is the Landsat 8 surface reflectance imagery. We can get the image from year of 2013 to 2024. This time we can get this imagery. Okay, and this dataset provider is that USGS. Okay, and this is the Earth Engine snippet. So Earth Engine snippet is the unique ID. So this is the unique ID of this image collection. So basically this unique ID stored the full image collection. Okay, so this is the unique ID. This unique ID stored the full image collection of Landsat 8. Also you can see about that all of band about the resolution about that it's a 30 meter. We can get all of band SRB1, SRB2. So all of band we can also get from here. Also you can see. So now this is my image collection. This image collection I want to import in my code editor. So this is my code editor. So how I can import this image collection? For importing this image collection, we can import the image collection in two ways. One way is that you can simply copy, just simply copy this unique ID. Simply copy this unique ID, just copy and then paste on your editor. Code editor, simply paste in here. And further, give a variable name. Okay. So we already know about that. Before the variable name, we must put here the var keyword. So just I put here the var keyword and then I put a variable name. Variable name can be anything. You can use any name. There is no limitation. Suppose I put the variable name is that L8 equal these things. So now this is my image collection. This image collection I store it in this variable. Okay. This full image collection store it in this variable L8. You can use any name. You can use any name. There is almost any name we can use. But some limitation is also have, but almost all of name we can easily use it. There is no problem. So here you can see this is the image collection. I simply copy from here. This is the unique ID. Simply copy and paste. Then give a variable name. Before the variable name must use here the var keyword. We already know about that for previous class. Then variable name anything. I can put the L8 and then equal sign. And this is our image collection. So now I just try to print how much image collection is available, how much images are available in this image collection, how much images are available. So for that, simply use at the print function and I call my variable name L8 and use at the size function and click the run. So now you can see here it computing how many images are available in this image collection between the time period year of 2013 to 2024. So now it show you that how many image collection it show about the whole world globally how many image collection is available between this time period year of 2013 to 2024. So it computing now. Okay, so if you face any problem for hearing or any problem for watching the presentation, then simply knock me WhatsApp. Then I can easily get this idea. Okay. Okay, so here you can see computing. It's very large number. Okay, so this is the total image collection. This is the total image collection for this Landsat 8 top of land surface reflective imagery between this time period, year of 2013 to 2024. Okay, so this is the total image collection we find out. You can see this is the whole world, from the whole world between this time period, year of 2013 to 2024. We find out this large number of image collection. So this image collection, now I want to filter. Okay, so how I can filter? Mainly it depends on the three factor. So mainly it depends on the three factor. One factor is the region of interest, mainly where you need this image. Another factor is that less than 1% cloud cover, basically it's filtering image properties. Another is that a specific time period when you need this image. So using this three factor, I just filtered this full image collection. This number show for the whole world. Okay, but in this time I not for the whole world, I need only for the my own study area. Suppose I need the image only for the Dhaka city region, I need the image only for that United States, I need this image only for that India or any specific boundary. So I filter my region of interest. So previous class I also discussed about that how we can easily import the shape file, okay, in asset tab, okay, as well as we also discuss about the data set. It's called the FAO. Basically it is stored that global shape file, mainly different types of district or sub district we can easily get from here for the globally. So just I simply use this shape file from here. Suppose I simply import these things in here, it will import it as a table. First, then I would use the similar code. Suppose I take a variable, suppose ROI, I call the table. This table I filter. How I can filter? Earth engine dot filter dot equal. What's equal what? Just I simply use their condition. They already provide the different types of properties for selecting the country. So just I simply copy this name, administration level 2. And then I paste here and I put the suppose Dhaka. Okay, so now what happened? This variable stored the Dhaka boundary shape file ROI. So I want to show the display. Suppose map.add layer, and I call the ROI, and further just use the map.center object for focusing on this boundary. So just I call here ROI and put at the 7 zoom level, click the run. So now it directly focus on the center of this boundary shape file. So now type of boundary, suppose this is my study area. Okay, so this is my study area. For this study area I want to need the Landsat imagery. Okay, so just I simply use this my Dhaka city boundary, or you can put any area of interest. It totally depends on your own work. Or if you want, you can simply just import your shape file. You can also import your own shape file from here. Simply import your own shape file from the asset tab, and you can also work with that. In this time I take this shape file from this data set. Okay, this data set provide me the Dhaka district boundary shape file, and now I want to need this Dhaka district boundary satellite imagery. Okay, so here you can see we find out that this L8 it stored the large number of image collection, but I need the image only for my study area. Okay, so this is my study area. I need the image only for the study area. So for doing these things, just I take a variable, suppose filter region. You can use any variable. Okay, there is no problem. I take the filter region name as a variable, equal sign. I call the large all of image collection, mainly L8. This L8 is stored this full image collection. Okay, for the whole world. But in this time, I don't need for the whole world. I need only for my study area. Okay, just I paste here. And then use a function. It's called the filter bounds function. Okay, so filter bounds function. This function mainly intersect the whole image collection with your region of interest. So now just I put the argument about that. Here you can see argument is the geometry. Okay, in this time I simply put here the Dhaka city boundary shapefile variable name. So now Dhaka city boundary is stored the ROI. So I simply copy the ROI and paste here. Okay, So now what happened? First of all, L8, it stored the large number of image collection for the whole world. So from the all of image collection, I choose only for those images which images are available in my region of interest. For that, I use the filter bounds function and add the ROI. What is ROI? This variable of ROI is stored in the Dhaka city boundary shapefile. So now let's check how many images are available in my Dhaka city boundary shapefile. Just use the print function again and call the filter region and use the size function. Just use the size function. Size function mainly computing how many images in a collection. So just click the run. So now we'll check how many images are available in the Dhaka district boundary. So you can see now it's computing another one. So here you can see we find out this result 536. Okay, so this 536 image collection are available in my region of interest. Okay, first of all, this L8 is stored the full image collection for the whole world, but I don't need for the whole world image collection. I need the image collection which image is available in my area of interest, suppose Dhaka city. So I find out that 536 images are available in my Dhaka city between this time period 2013 to 2024. Between this time period, I find out that 536 image collection. But from 536 image collection, I choose only for image which image is will not be more than 1% cloud covered. I need only for those image which image will be not more than 1% cloud cover. So I filter image properties. So now I filter the cloud properties. I select the specific less than 1% image I need, less than 2% I need, less than 5% I need. So for that, just take the another variable. Suppose I take a variable. You can put any name as a variable. I put the variable name, suppose filter metadata, or you can put any name. So now this 536 images is stored in a variable. What is the variable name? Filter region. I simply copy the filter region and paste here. And now I put a function filter metadata. Okay. This filter metadata function filtering the image properties. Suppose here you can see the image properties. Image properties. So now I filter the image properties according to cloud cover. I need the less than 1% cloud cover images. So suppose I cloud cover, this is my image properties name. So now you can check about the argument about this, just control and space. We can get all of argument about this function. Here you can see one is the name, operator, another is the value. So name mainly cloud cover, image properties name. I simply copy it. And further I just put here name is the image properties name, and then operator mainly I put here the less than 1 because I need the less than. So just put here less than and set the value for 1. So I set the value for 1. Value for 1. So now I just print that and let me check how many images is available which is the less than 1% cloud cover for my study area. Simply copy this filter metadata and paste here, and then use the size function, and now click the run. So now you can see it computing for my study area how much image is available which is less than 1% cloud cover. We find out 83 images is available for my study area which is less than 1% cloud cover for my study area. Okay, but this, what is the duration? What is the duration? This duration is that between this time period 2013 to 2024, but I need for a specific time period, suppose summer season, rainy season, or a specific month or a specific year. For filtering the time, we just take the another variable. Suppose I take a variable, any variable, you can put any name as a variable. Suppose filter date. So this 83 image is stored in this variable. I simply copy the variable name and paste here, and then use a function filter date function and put here start date and end date. Okay, suppose I put the date, suppose year of 2023 1st January from year of 2023 December 31. Okay, so this is my time period. I simply put in here. So now how many images are available for this year? So simply use the print function and call the filter date and use the size function and click the run. So now it computing how many images are available between this time period. So we can find out that final result 9 images. Between this time we find out the 9 images. So now this 9 images is available in my area of interest. This 9 images is less than 1% cloud cover, and this 9 images is available between this time period. So basically according to this 3 factor, so here you can see this 3 factor. First of all, where you need this image, then how you need this image, mainly 1% cloud cover, and then when you need this image. Suppose I need the image in year of 2023. So basically you just remember that this function, first of all, where you need this image. Then second one is that how mainly less than 1%, less than 2%, less than 3%. Suppose how you need this image. And third factor is that when you need this image. Okay, so where, how, and when we use, and then we filter the large number of image collection. So first of all, this variable L8, here you can see this L8 is stored at the large number of image collection for the whole world. But I don't need for the whole world, I need only for my region of interest in Dhaka city. For that, I just take my boundary shapefile of Dhaka city and I use the filter bounds function. So L8, this variable is stored the large number of image collection, mainly full image collection. Okay, I use the filter bounds function and put my shapefile variable name. Shapefile variable name I put ROI. So just I use the ROI. So now I find out that how many images? I find out the 536 images. But I choose the image which is less than 1% cloud cover. So from 536 images, I find out 83 images is the less than 1% cloud cover. So then finally from 83 image collection, I just choose only for those images which image is the available between this time period. So I find out the final 9. So now I want to check more information about this 9 images, this 9 image acquisition time, all of things I want to check it. Because between this year of 2023, this 9 image is not captured at the same time. It captured the different time period between the year of 2023. So for that, we have to check about this time, all of information for 9 images. For that, simply print this filter date and click the run. So now it shows you all of information for the 9 images. So here you can see this is the 9 images. Just I click on here, feature. You can see about all of images information from here. So let me increase this side. So here you can see every image have a total 19 bands, and you can see the first image acquisition time 18 January, then 7 March, 8 April, 2nd November, then 3rd February, then 8 April, then 2nd November, then all of that we can easily get from here. Okay, suppose I click on here, I can get all of properties. Suppose this is my first image, I simply click on here, I can get all of properties. So here you can see cloud cover 0.1, so less than 1 we can get the cloud cover, as well as also other information for this image here we can easily get it from here. All of information, all of properties we can easily get from here. So now I want to visualize the image. Suppose this date image, year of 2023, 18 January, this image I want to display on my map. Okay, so for that I simply click on here and copy this ID. This ID I simply copy. And further, in my code, just take the another variable. Suppose I put the variable name is that image. You can put any name as a variable. Then put here ee dot image, this function, and copy this, paste the ID. Okay. So now display the image. Just use here map dot add layer and call this image. Click the run. So now this time period image is loaded in our study area. So here you can see it's loaded, okay, as a tiles. So basically this tiles acquisition time is that year of 2023, 18 January. This time, this tiles is the generated. And you can see this tiles is not fully fill up my study area. Okay, so this tiles is not fully fill up for my whole study area. So for that, what can I do? For that, you check the another image. Suppose I check the another tiles, another acquisition time imagery. Just I click on here, and then I check it from the feature. Okay, just a minute. Just I click on here and let me check the another imagery. Suppose I check it this imagery. What's happened about that? Simply copy this ID. Simply copy this ID and now paste here. Just paste. So now let's check what happened for this imagery. It also same. It also not fill up the full study area. So you check when you want to work for that. You also check for which tiles is fully fill up or fully overlay with your study area. So suppose I check the third number image. Just copy this ID. And paste here. Click to the run. It also not working. So you check the another. But it also another solution. But first of all, I will show you the single image, because some analysis we also need to work for the single date image. Suppose let me check about this image ID. I simply copy. Okay, so now here you can see these tiles is fully fill up my study area. Okay, so now I can easily use this time period image year of 2024, 23, 8 April. Okay, you can see this tiles is the fully fill up. When it fill up, just I use a function, clip function, clip with my study area. My shapefile variable name is ROI. Just I put the ROI, click to the run. So now I can get the result only for my study area. So here you can see it look like that. So it's the default visualization, but we are also add here the color band combination, then we can get the more better imagery. So it look like that. It's the default visualization. So now I want to add the visualization. So just click on here. You can see this is the two layer. One layer is my boundary, another layer is that imagery. So just I click on here, setting properties, and here from here you can easily add the different types of color, different types of band combination. Suppose red band, then green band, and blue band. Okay, it's called that RGB. Okay, when I put the red, green, blue, then I can get the natural color. And custom stressing 98%. So basically you can see different types of stressing level. Stressing is one kind of data visualization process. So when I stress 98%, then it stressing my full data set between their mean and max value, and then show the visualization. So just I use the 98% and now apply. Now let's check what happened. Yeah, we can get this type of imagery. So it's the natural color band combination. Okay, we can easily get that natural color band combination look like that. And here you can see this image is very clear because we choose only for the less than 1% imagery. And we find out this time period, year of 2023, 8 April, this tiles is fully overlay, fully fill up my study area. So now I can easily use it as a single date image. So it's called that single date imagery. Okay, so now from here you can use the different type. You can see here I just simply add the visualization. This is my layer visualization parameter option. Just click on the import. So here you can see when I just click on the import, a new line of code added in my code editor. Just import, you can see this code will be added. Okay, I simply copy the variable name and paste after the object name, mainly our object name. This is our object. Okay, then we put here the visualization parameter. So I put the visualization parameter and then I put the layer name. I put the layer name, suppose true color, or we can put any name. Click the run. So now it will be set with our code.
Hello.
Yeah, please.
Yeah, thank you very much. This is very, very interesting, by the way.
Yeah.
Just a quick question. Now we have done a good exercise, but now we are taking only image for the city without any, we can call it property like vegetation or land surface or any climate conditions. Just pure image of the area, right?
Yes. It just show about that pure image of this area which is less than 1% cloud cover.
Yeah, but my question is, if we do the same for any other property, like anyone want to analyze any property, and we go for image through the year, are going to get the same result, like one image or five image, or are going to get lots of images where through the whole month, so it will help us? Because this is like filtering and coming back with a shortage of only 8 or 5 clear images in the year. This might make a problem for any study or analysis, or
Okay,
might
so
not.
first of all, you have to check it for your study area. Less than 1% image is available or not. Suppose when you want to work for that coastal area or river bank, for this we did not find out the 1% cloud cover imagery. Okay. First of all,
Yeah,
you have to check
but
it.
you find only 8 images for the year, the whole year, even not covering the whole area of interest. So you find maybe out of 8, maybe 1 or 2 images. This will happen if it continue like that. That means maybe some areas it will be very hard to make a study on, maybe because some parameters might lack of images. Is that correct?
So if there is no image, suppose some reason is not 1% image is not available, then we have to increase the cloud cover level. Okay.
Aha, okay,
Suppose
okay.
you can see
So
here
that's
when I increase the cloud cover level, what happened? You can check. Suppose I put here less than, suppose 10%. Okay, we find out that less than 83 imagery. You can see. Okay, less than 1%, 83. But when I run the 10, less than 10%, then this collection is also increased. So now let's check how many image is available, which is the less than 10% cloud cover. Now it will be show the result 176. Okay, so this 176 image is the less than 10% cloud cover. Okay, suppose you can put at the 90%. What happened? You can see, because some region such as some coastal area or other region, you don't find out that less than 1%, 2% is not available. You don't find out. So further you have to use the 90%. And when you add the 90%, then you can find out the lot of cloud pixel, lot of cloud. We can find out your imagery. Okay. So further
But
we
this will
also
not
discuss
impact the
about that
results?
how we can easily remove the cloud. So further fourth number class we discuss about that, because when you increase this value, you must find out the cloud in your imagery. But this is the another solution for that. We also use it and remove all of cloud and get the more clear imagery.
Perfect.
Yeah, it also
That's
possible.
brilliant. That's
Yeah.
brilliant.
Yeah.
You are a brilliant guy. Thank you.
Yeah. Okay. Okay, so in this time, Dhaka city is not the coastal. Easily we can find out that 1% image, less than 1%, we can easily find out. But some study areas such as coastal or river bank or some area, they are all time they are make the cloud formation or condensation. So that's why we also add the 90%. And when I add the 90% cloud cover, there are a lot of cloudy peaks you can find out. So that's why we also need to apply the cloud marks or cloud remover function. This function help me to remove all of cloudy pixel and get the very neat and clean imagery. Okay, so here you can see we can get the single imagery look like that. Okay, and it called the natural color. But in the band combination, suppose band combination mainly we are using the 3 band. I simply search on the Google. You can also check the link. Suppose band combination of Lancet 8. So just I simply search there from this website. We can easily get the different types of band combination, and we can basically this type of band combination useful for identify for the different types of feature on the surface. Okay, suppose as well as band ratio, it also very helpful to identify for the different types of mineral. Okay, so basically we are using the different types of band combination to identify different types of feature on the surface, such as red, green, and blue band or other types of band combination. You can easily find out. I think some network issue, that's why it not loaded. Okay, loaded just a minute. Okay, you also check the link later. I also send the link in our Google Classroom. Then you can easily get that more information about the band combination. So, okay, suppose I want to add the another band combination, such as I simply click on here again, and I want to add suppose near infrared, mainly band 5, then red, and put at that blue. So near infrared, red and blue. So it's called the false color composite. So just increasing and stressing 98% again and apply. So now I can get this type of visualization here. You can see. So now this red color, it's identify about the vegetation. Okay, water body show as a black color or dark color when I use the this type of band combination. So further I also discuss later about that, because we also discuss about the land use land cover classification. When I talk about the land use land cover classification, I also talk about the more details about the band combination. So now I want to add it. So just I simply import. You can see another visualization parameter is also added. So just I simply copy these things and I want to add with my layer. So further I take the another layer, map dot add layer, and I call the image and paste here. Okay, and I put here the name. Suppose I put the name is that false color. Okay, so now click and you can see in this time it added the another layer which show the result for false color. Okay, mainly false color when I add, then we find out the vegetation as a red color. Okay, so this type of red color identify about the vegetation, and water body show as a black color or dark color. Okay, this type of color. Suppose I show you the another example. Just I click on here, I add the another band combination. Just I simply click on here, and then suppose it's called that short wave infrared 1 band, mainly B6 short wave infrared. Then put here that near infrared, mainly B5, and put here the green band, so B3. So stressing 98% for better visualization, and then apply. So now we can get the another band combination. It's very useful for identify for agricultural land, vegetation. It's very important for that. So here we can get this type of things. We can find out this type of gray color identify about the barren land. So it's also very helpful. Suppose I want to add it as a layer. So just I click on the import button. You can see another visual also added in my here. I simply copy. And now I just take the another layer. Suppose put here map dot add layer and call this image and paste here. I put the layer name, suppose agriculture, or you can put any name, agriculture. So just click to the run. So now you can see it added the 4 layer. Okay, first layer is my region of interest. Second layer is that true color or natural color. So all of layer I can easily add. Okay, so further, suppose when I discuss about the land use land cover classification, then this type of band combination is very helpful to take my decision. Is it water body? Is it vegetation or agricultural land or water body or barren land? So I discuss further more details further class about the land use land cover classification. So now I will show you that how you can add the different types of band combination. You can see using that we can add the different types of band combination. Okay, we can get it look like that, and it show only for the single date image. Okay, single tiles. Suppose this tiles acquisition time is that year of 2023 8 April. Okay, so this time this imagery acquisition, but suppose at the same time I need the image for the big study area. Suppose whole country boundary of Bangladesh or whole country boundary of India. So for that, one tiles is not enough. Okay, one tiles is not enough for my whole country boundary of Bangladesh. For that, I need to merge all of imagery, all of tiles. Then we can easily get it. Suppose here you can see, suppose I simply search here. It not appeared yet. Okay, so in Bangladesh, for student movement, still now all of internet connectivity is not work very well, so that's why it's not opening. Okay, so now only work for the broadband connection. Mobile internet connection is totally off, so that's why it create this type of problem. Okay, I'll send the link, no problem. Suppose I simply search here. Suppose Bangladesh tiles land set. So here you can see, then we can easily get the picture look like that. In this picture here you can see for the full Bangladesh how many tiles we need. We can see 1 2 3 4 5 6 7 8 9 10 11 12. So 12 tiles make the cover the whole country boundary of Bangladesh. Okay, so that's why when you want to work for the single date image and take the image for the whole country boundary of Bangladesh, then it's not possible, because one tiles is cover this area. Okay, another tiles is covered this area, and all tiles is not captured at the same time. Same date is not captured. So this type of tiles captured at the different time. So let's say we try to make the image collection for the whole country boundary of Bangladesh. Suppose then we have to use the another way. It's called the median. Okay, we create the composite. So suppose here you can see it show about the single date image. So this is the process for single date image. You can apply for any other study area, same process for the single date. But we are also applying for a merge all of image collection. Suppose here I find out the total 9 images for my Dhaka city. I can easily merge all of image collection and create the composite. Total 9 images I can easily merge. So now I talk about that composite image collection. For composite, we can use here the different types of composite. One kind called the median composite. Another call about that mosaic composite. Okay, as well as sometime use here the mean composite. Okay, so suppose I use the median composite. Okay, so total 9 images middle pixel value I take and create a new image. So it's called the median composite. So for that, suppose I take a variable, suppose final image equal sign filter date. This filter date is stored at the 9 images. Okay, so now I want to create a median composite which combine total 9 images middle pixel value and create a one image. So just I simply copy the filter date and paste here. Just copy the variable name and paste here, and then use at the median. Okay, so now further you can see when I just use the map.add layer function of the final images, just I copy and paste here. So now total 9 images middle pixel value combine and create this composite. You can see the result. You can see. Okay, so you can see it covered the whole area also about that. This my study area. This my study area. It also cover as well as also show the large area. Okay, so all of tiles, total 9 tiles is make the median composite, and we can get this type of imagery. Okay, so in this time it's a single image, but this single image is generated from total 9 images middle pixel value between the time year of 2023. So now I simply use the clip with my study area. Suppose I just use here the dot clip with my study area which says ROI, click to the run. So now we can get the result only for my study area. But now this image is generated from total 9 images middle pixel value. So this layer. This layer. Further, you can simply click on here and you can add the band combination and also add the visualization. But this image is not single date image. This image is created from total 9 images middle pixel value. Total 9 images median composite this image. Okay. So I simply add the suppose red, then green and blue. And it's very important because when you want to work for the big study area, such as whole country boundary of Bangladesh or any big study area which is not fully covered, the one tiles is not fully covered, then you simply use the median, then it will be okay. Okay, suppose I stress in 98%, and now I can easily add the band combination natural color for this. But this image is for median composite. Okay, this image is created from total 9 images middle pixel value. Okay, and it's very important for the big study area. Suppose you make the for a whole country boundary of Bangladesh. So let me show you the example for Bangladesh country boundary, then you'll see more better. Suppose I simply import from here, just import. Okay, you can see it will be imported the shape file table 2. You can change the name. Suppose I put the name is that BD, or you can put any name. So now I want to need the satellite image for the BD. So for that I simply just comment this line. It's not need because in this time BD is my shapefile boundary variable name. So just I use here suppose I put here that map.add layer for BD. Also I add here the map.center object for BD because in this time I ignored the ROI variable. I put the variable name is the BD, and I filter bounds with my study area. I put here the shapefile variable name BD because I put the name as a BD. Okay, then also it's okay, no problem, just keep in the same. And further I just click with my BD. Okay, so now it show about this result. So just I click to the run. So now it show the result for whole country boundary of Bangladesh. And here you can say I can get the problem. It show about the ROI because I removed the ROI. So that's why it looked like that. So just I simply commenting the full study area, just commenting. So now click the run. So now it show about this satellite image for whole Bangladesh. Time period is the 2023. In the 2023, all of less than 1% image create this composite. Here you can see. So it look like that for whole country boundary of Bangladesh. And further I simply just add the visualization from here. Suppose I add the visualization for okay, I add the suppose short of infrared one, then near infrared, and then put it at the green, custom stressing 98%. Then we can get that median composite for whole country boundary to Bangladesh year of 2023. But this is it's not a single date image. It's the combined all of images. You can see how many images combined in this time. We can also get it from the console tab. You can see about that 71 images. Okay, 71 images combined, and this 71 image is the less than 1% cloud covered. So year of 2023, we find out 71 image is the cloud cover image, and this composite I created for using the 71 middle pixel value. Okay, so you can see now it fully cover my study area. For whole country boundary of Bangladesh, we can get this type of imagery. So now we can easily make the NDVI map, or you can easily make the land use land cover map, or any other remote sensing application for the whole country boundary of Bangladesh. You can easily do it very quickly. Okay, so this is the use of composite. But single data image, it also need for the small study area, for that monitoring for the different types of things. I was flood monitoring or different purpose. It also used for the small study area. We can easily use the single date image. But for the big study area, it's not possible because single tiles is only have a tiles. Okay, in Bangladesh we find out that 12 tiles is covered for the whole Bangladesh. Okay, so that's why we are just make the median composite. So now we can easily get this type of imagery, and further we can also make the land use land cover map or NDVI map or other remotely sense analysis. We can do it. So this is the process for the median composite, and this is the another process for single date imagery. So I hope you can easily get the idea how it will work for the single date and median composite. Further also talk about that other mosaic or mean, these type of things further also discuss about that. So in this time median, mainly median take the middle pixel value. So in this case 71 middle pixel value create this composite. Okay, further we click with that and we can easily get this result look like that. Okay, so anyone any question you can ask me. Yes, please. Yes.
Hello, can you hear me?
Yeah, I can hear you, please.
Yeah, thank you. Just a question. When you work on it, you make because you make the code inactive with one click. How you did that?
One click means?
Means like you select all and then you make the whole code inactive. You added the.
So just I simply first of all simply select. Suppose I can say select using my mouse and then press Control and forward slash. You can see it will be uncommenting now. And when I click on the Control forward slash, it will be commenting.
So Control F, both sides will work, either back and forward, right? Yeah, okay.
Yeah, Control and forward slash. Basically, this sample. You can see this sample in your keyboard. Just press Control and slash. Okay. Then it will be at the same time. It also work. And okay, so this is the process about that for that final media. Here you can see I used a lot of code for this getting this type of imagery, but we don't use this type of code. We just use very short code. For the first time, for understanding one by one, I use this type of lot of code. But when I write the code, very quickly we write the code within 4-line code, we can easily get the imagery. Okay, so in this time here you can see for individual function, I take the individual variable name. For filter dates, I take a variable name. For the filter metadata, I also take the another variable name. For the filter date, I also take the another variable name. Okay, but if you want, you can just take only for the one variable, and under this variable, I add all of function. Okay, so let's show you. I will show you this how it will work. So for that, I simply comment all of things. You can see how I can comment. Simply select, and then press Control and flush. So now it's commenting. You can see everything will be comment. So now this code is not work. Okay. So now suppose I take only for the one variable L8. So this is my image collection. Okay. It is stored at the full image collection. But I need this image collection for my study area of Bangladesh. So just I simply use the filter bounce function and put the variable name of Bangladesh shapefile BD. Okay. Then I simply put here the filter metadata and I choose the cloud cover level. I put the properties name cloud cover and I put the operator less than 1. Okay. And further put the dot and I put here that when I need this image, basically filter date function, and I put here the year of 2023, suppose 1st January from year of 2023 December 31. So now I can say filter my image collection. So first of all, where you need this image. Okay, where you need this image. Then how you need this image. then when you need this image. Okay, so here, how, when I filter my image collection, and what is my final image collection, I need to check it. So just use here the alert and use here the size function, click the run. So now here you can say I find out that how many images according to this condition, after filtering my study area, after filtering the cloud cover, after filtering the time period, we find out the 71 images. It show for the whole country boundary of Bangladesh. Okay, 71 images, and this image is the less than 1% cloud cover. If I increase it, suppose 90%, then here you can see it also increasing my image collection also. In this time, it also consider about that 90% image, 90% cloud cover image also. But in this time, it not need. But further, I also show you that how we can easily increase this cloud cover level and also remove the cloud for further. I think it will be covered in the 4th number of class. We discuss about that for removing the cloud. Okay, so now you can see you get 326 images. We find out that less than 90% cloud covered. Okay, so I choose the low cloud cover because in this time it is available for my study area in Bangladesh. I put it the less than 1%. So this is my image collection. Okay, here you can say simply use the another function. So now I find out the 71 images less than 1%, and I want to create the median composite. And when you need the median composite for the big study area, okay, suppose whole country boundary of Bangladesh or any big study area which is not fill up the single tiles. So you can also check about these tiles. You can simply use the print function and use here the L8. So now I can get all of image information. So here you can see it show about the total 71 image collection. If you want to add the single image, it not fill up. Suppose you can see 71 image collection from here. So all of images, also that time period, you can easily get it from here. Suppose from here, you can use any single date imagery. Suppose I will show you that. Suppose this image I want to use. Simply click on here and then copy it. Okay. So it's one kind of tiles. Acquisition time you can see 11th. You can see 11th November. Okay, 2023. I simply copy and I want to add the single date image. Take a variable. I put the variable as suppose image and use here ee dot image. Just paste here. So now display this imagery. Just use here map dot add layer and you can use here the image. Click the run. So now it show about this image which is captured this time year of 2023 11th November. So here you can see it covered this area. Okay, single tiles. It's covered this area. So for the whole country boundary of Bangladesh, one tiles is not enough. So for that we have to use the help of median function. So all of image we just make the median composite. So for that in this time it's not applicable for the whole for big study area, but a small study area we can easily find out that single date image, no problem. So for that I just simply use here the dot median. So here you can see now it's very important. When I use here the median, then this variable is not a collection. Okay, when I put the median, then this variable is not a collection. It's just a single image. So I click to the run, you can see it show a problem. It show about that L8 size is not a function. Okay, because this size function is only work for collection. But when I put here the median, then this variable is not a collection. It's just a single median image which is created from total 71 images. Okay, when I use here the median, then it's not a collection. And size function is only work for the collection. You always remember that because further for make the time series chart, there are a lot of uses. Okay, you can see when I remove the median, then it also worked. It also worked. There is no problem because now here how and when I filter, it is a image collection. Okay, but when I put here the dot median, then this variable stored the single median images which is created from 71 middle pixel value. Okay, then this size function is not work. Size function is only work for single size function is only work for the collection. But when I use the median, then it's not a collection. Okay, so you can see it not work. It shows the problem. This problem because this size work only for the collection, but when I put the median, then it's not a collection, it's just a single median composite. So just I commenting these things. You can see when I print that, it also work. You can see it show about the image, not image collection. So L8, when I print the L8, then I can get that image. It is a single median composite image. And how much band have? Total 19 bands. So now I can easily display this imagery. So just use here map dot add layer and put here that L8. Okay, and further I simply copy the previous visualization parameter. I just, or if you want, you can also add the new, no problem. Suppose I run the code, and further from here I can also add the visualization for from these layers. Just click on here, and then I add here suppose another band combination, red. Okay, you have to use the clip function also. So here you can see after use the median, we can get this type of result. Okay, because we are not clip with our study area. So just use the another function clip. So now we can get the result about that clip with BD, because BD is the shapefile. So click the run. So now it's clipping with my study area, and I can get the result only for my boundary of Bangladesh. So now I add the color. Suppose click on here and add here suppose red, then green and blue. Custom stressing 98%. And further just will be just when it will be okay, then we apply, click the apply. So now it's working. Okay, done. So click on the apply. So now this visualization also added in my map. Okay, here you can see it will be added the true color composite. Look like that. And these things I also want to add in my this visualization. I want to import. So just click on the import. You can see it will be added the new line of code. Simply copy and paste after the object name. So L8 is my object. From the object, I just paste here the visualization parameter, and I put the layer name. Suppose I put the layer name is the true color. Click on. Okay, so here again, so we can get this type of imagery for Bangladesh. So this code you can also use for the other country. Suppose I show you the another example. Other country means that suppose I simply search here US DOS dataset. We already know about that. I simply import. So from table 2, we just take the country boundary shapefile for the different countries. Suppose I just take a variable. I put the variable name, suppose ROI, or you can put any name. I call the table 2. This table 2 I want to filter. How I can filter? Earth engine dot filter dot equal. What's equal what? I put here the country name. Suppose I put the country name, suppose Pakistan. Okay. So now I simply change my study area. Suppose filter bounds with ROI. I just paste in here, and also clip with my ROI. Click with ROI. So now click to run. We can get the result for Pakistan 2023 imagery. We can get it, but it not focus. So for that, I simply use the another code map.center object. So map.center object. So it's the directly focus on my shapefile. My shapefile is the Pakistan. It is stored the ROI. So just I use here the ROI and put here the suppose 10. Click on. So now it visualize about that Pakistan. You can see we can get it. So any country boundary shapefile you can easily get it. Look like that. So it's about that Pakistan 2023 Landscape surface reflectance imagery. So now further you can easily use it for making the different types of analysis for vegetation or indices or land use, land cover, land surface temperature, or LST monitoring, anything you can easily do it. So you can see we can get the imagery. So any country simply sends the name. Suppose I put the name for Australia. Click run. So now I can get this 2023 Australia Landscape surface reflectance imagery. It shows the true color composite because I already show the true color. So you can also change it from here for the different types of band combination. Where again, so you can get this type of imagery. Okay. Or any country boundary, simply search here. You can also change your time period from here. Then it also okay, no problem. Suppose I simply search here, say the Arabia. Click run. So now it's about that Saudi Arabia land set surface. In this we can get this type of imagery. Okay. It will be work because in this time, in this code, we are just use here the median function because all of images create the median composite. Okay, so when you want to work with the median, then it also work for that. But sometimes you can see when I work for the single date image, suppose you can see this image is for a specific region. Okay, this time this image is only for the specific region, this single date imagery. Okay, so then for that we cannot use it for other region. But when I use at the median, then we can easily apply it for any region because this it take the imagery for this region and make the median. Okay, any question you can ask me.
Yes, please.
Yeah.
What do you mean about median? Median means we'll take put them in sequence and take the like statistics, take the median.
Yes. So
between them,
median
like
mainly in this time,
lower and
suppose
higher. Yeah.
I have total 71 images. So this total 71 images take the middle pixel. All of images take the middle pixel and create this composite.
And when he does that, that means he'll take also the band for that image only. He ignores also, or he will call only the bands of that image. That's all.
Yes.
Okay. But this is an analysis. We have to use the median, or we can do the analysis
It's
for all
depend
bands,
on
or
your
we do it
study
only with
area.
one.
Suppose your study area is not fully fill up the one tiles, then you have to use the median. Suppose such as for you want to work for the big study area and big study area is not fill up for one tiles, then we just make the median composite and we can easily get this imagery.
Just to keep my understanding, proper understanding. For example, this median, I can write a code. I know which month and which day this median is, right? I can know could be this median coming March 15, whatever, right? For example.
Yeah. So in
or
this
could
time,
be
this
because it's
image
singular.
is not capture any specific time. This image is generated from total all of images in year of 2023. Okay. So between this time,
it's not one image.
Yes.
Yeah. Because when you write median, I thought they will just pick up one of the images in between all of these images. So if I have 83 images,
Yeah.
just pick up only one image, which is, I don't know, this is my understanding. But if you pick up one image, it will be for only one specific day.
Yes, it's also possible. Suppose you can see here, I show you that. Suppose I just commenting these things and also open the print. So now it's about that all of images between this time period. From here, you can simply choose the specific date image. Suppose you choose the some images. Suppose here you can see it's about that, and then we just also merge it and work with that. It also possible. Suppose from we find out that 446 images. So from here, I just choose 5 images from here. I simply choose the 5 images, and further these 5 images I simply create merge and also work with that. It also possible.
Yeah, but what my question is, when he does the median, he will choose the best, or just put in order, or just do it randomly, and he will take only one image. That means he will select one one image from all this one, four, six images, right? We'll pick up only one, the median one, right? This is my
Yes.
understanding. So this median one, if I do analysis on the median one, that means I'm doing it on 1 day analysis. Even if I put my day is different, then in the future when I do an analysis, it will not find data for that day because the median is happening on different day.
Yes, for that we have used the single date imagery, but sometimes single date imagery is not covered the full study area. Then we have to take, suppose, how mass tiles is cover my study area. Then further we can just merge. Sometimes we also use the merge. Sometimes we also use for the median. Then work with that.
Okay, so the image now has, you said the image has bands, right? So
Yes.
that means these bands take up, which is measuring data now.
Yeah.
For example, but X, Y, Z, that's it. So if I have one image, this image happened on a single day, right? Every
Yes.
image
Yes.
happened on a single day.
Yes.
And on that single day, you have these bands available, right?
Yeah. Yeah.
So with this, that means I have, say, if I have 10 bands, I have only 10 bands for one image only. And from that one, I will do calculation for that day only. But if I pick up different day, it might not get the band. For example, if the image for March, and I need to do analysis on July, so that means the band is measured on a different day. I cannot use that band on March to calculate something happening in July. Or I'm not understanding it very well.
Okay, so I will again explain about that. So first of all, we get the two types of imagery. One is the single date, another is the median composite. Single date is available. Single date mainly it's a single times. Okay, so mainly satellite image acquisition time. Suppose this is the one kind of imagery. This time is that year of 2023, 8 April. Okay, this is a single date imagery. And we can easily visualize it for my small study area because a small study area easily overlay this image. There is no problem. But when I work for the big study area, then one tiles or two tiles or three tiles is not enough. So for that, we have to create the median. Or if you want, suppose here I can get total this number of images. From here, I choose a specific tiles and then I merge it and also show it will also fill up or not. It also another way. Okay, it also possible to show this result. So overall, mainly for the big study area, we are using the median, and a small study area, we can easily find out the single date imagery. Because in year of 2023, all of image is not captured at the same date. So it captured the different time period in the year of 2023. So in the year of 2023, all of images we create the median composite. So now you can easily get this imagery for any study area. You can easily get it. There is no problem. And we can also change it for the band combination from here. Okay. Okay, so this is the way for filtering. And in the same way, you also try for other image collection, such as Lancet 7, Lancet 5, okay, Lancet 9, you also try for your own study area. Just simply upload your shapefile and also give some assignment regarding this today's class also. So just you can simply try for Lancet 9, Lancet 7, Lancet 5, Lancet 4. Lancet 7, you also get some other problem, such as you find out that scale line error or gap error you can find out for the Lancet 7. So you also try first, then we try to discuss about the solution for the scale line error or gap filling. This with Lancet 7 you can get mainly this type of problem. Lancet 5 is also okay, no problem. So you also try for the other image collection, same process. You can create the single date imagery for your study area as well as also make the median composite for your big study area. Okay, I also put some assignment regarding this topic. Just do it, and further face any problem, they also guide you. No problem. Okay, so using this process, you try for the Lancet imagery. All of is the same process for Lancet 9, Lancet 8, Lancet 7, 5, 4, 1 to 5. You also try. So now we talk about the MODIS, another data set. So in this time, here you can see MODIS. It provides the different types of ready-made product. Some product is the daily. So here you can see the daily product. So it provides Modis is also available for that LST. Okay, it's also available for the Aqua dataset. You can easily get it from the Modis dataset. Okay, so after creating this type of map, we can easily export it as a TIFF format. We already know about that. So just use the same code for exporting. Just use your export image to Drive, and just further apply all of code one by one. I hope you can easily do it, and then you can easily export it, and then further work with that ArcMap or QGIS software to produce this map. So here you can see, yeah. Okay, one map is successfully installed, but another is not yet exported. Okay, not enough space. Oh, okay, sorry. So in this time, my Google Drive have not much space. Okay, so that's why this image cannot be downloaded. Okay, so it's a very high for net 3.1 gigabyte. Okay, so my Google Drive have not this type of space, so that's why for this satellite image is not exported. Okay, so you also check your Google Drive before working with big exporting the big file. Okay, so it's a big file, so that's why it need the 3.1 gigabyte free space. And now my Google Drive is not have this type of enough space, so that's why it not exported. But another map is also exported, so I'll show you that how to do it. Just click on here, and you can see about that open in Drive. So now it open in Drive. Here you can see. So you can see almost finish mine. Only for the 4% is available. Okay, my story is already fill up. So let me delete some. So I download it. You can see Columbia NDV. I simply download it. Download. Okay, click here. Download it. Okay, so I think some networking issue. Yeah. Okay, download anyway. Okay, it also starting the downloading. Okay, so in the meantime, I also try to remove this type of file because the storage is already. Okay, you can see it is downloaded. Okay, so further we can easily open it in ArcMap or QGIS software and then make the map layout. So these things I also show you that fifth number of class. Okay, so this is the process for downloading the TIFF image, I think, from Google Earth Engine. Okay. Okay, so any question? Okay, so now we back to our problem solving class for previous days. Anyone have any problems? Just simply share your screen one by one. Then show me your problem. I will try to solve this issue. Okay, so any question or any problem, you can ask me.
Sir, can we do prediction or modeling of that temperature
Yes.
that you have shown on the graph, sir? Can we predict for the further for next for like you have seen for we have seen calculated for the July till July we have calculated
Yeah, it
temperature
also possible for
and I want
predicting. Suppose you can use here that I already make some tutorial about that. You can also follow. Suppose after downloading the data set, suppose I will show you that. Just a minute. I open it and show you that. So in the Python, suppose you download the data. You have a time series data. Then further you can also try to use it for getting that prediction. Okay, so basically we can get the data from here, then we can easily use the different types of Python library, and then we can easily get this result, no problem.
You can do more than you can do before.
Time series prediction. Okay, let me open it. So see it run. Yeah. So okay. So here you can see I will show you the one example for that prediction of NDVI value. using that ERIMA. ERIMA is one kind of method for time series prediction. Okay, so then we can easily do it, no problem. You also try to watch this video, then I hope you can easily get the idea how we can easily work with for prediction for time series chart from our, suppose you have a time series chart of NDVI or LST or any other. So now you want to predict based on the previous data. So you can easily do it using this tutorial, I hope. Okay, so try to check it further. I hope you can easily get this idea how we can easily prediction for NDVI or LST based on the previous data. Okay.
Okay, sir.
Okay, so any question?
Sir, in case of air quality also, can we predict for like we get calculated the data of 1 year and afterwards we can calculate if
Okay,
the
so basically
study
in this
area.
time, it all air quality. Okay, so it also possible, but this result is not much good because for air quality is also depend on the different factor. Okay, so if you including the factor, then it also more better. Otherwise, we can also do it using this same process, but this result is not much good. Okay, it also possible, but this result is not much good about that.
In terms of water quality, sir,
For water
in terms of water
quality,
quality,
yeah, same process you can also apply for that. Okay, no problem. It was possible.
so for water absorption,
So you can also do it. Suppose based on the previous year data, what will be future? Okay, first of all, we find out the trend using the linear regression y equal to mx plus c. So further from here we can easily predict. It also possible for prediction using the linear regression
what
model.
you told reflection, water reflection. So water
Yeah.
absorption spectra is available there for with satellite image.
Yeah. Okay, so any question?
So water absorption spectra is there for the groundwater quality.
It also
As
possible
you mentioned,
using the ERIMA. Yeah.
surface reflection.
Okay, so you also try to watch this video. I hope you can easily get it for the time series, how we can easily predict the time series based on the previous year data. Okay, for the future time series. Okay, also I hope you can easily get this idea. But this method is not enough because a lot of factor is also influence for that this type of air quality or also water quality. It also involve this type of things. But as a time series chart, we can easily predict. Okay, so any question
Okay, sir. Okay, no problem.
or any problem for the previous class or assignment? Okay, so if there is no question, then we'll be in here.
Can we sir, if any problem is there, can we ask in WhatsApp group?
Yeah, WhatsApp group we create for that, for the problem solving class. When you face any problem, you can simply just knock in the WhatsApp group or also Google Classroom. So better for use the WhatsApp group because WhatsApp group I always active, so you can easily ask any question in the WhatsApp group anytime. Okay.
Okay.
And okay, so today's session will be in here, and I also give the for today's session recorded class and also practice code and also assignment. You try to do it, and further face any problem, you can just ask me in the WhatsApp group. Okay.
Thank you. Thank you.
Okay, thank you. And the next class will be held in the Friday at the same time. Inshallah, we'll meet and continues for the third number of class. Okay. So any question? Okay, thank you. Okay. Okay, have a good night. Okay, bye.
Thank you, sir. Good night. Thank you, sir. Thank you.
Okay, bye.